What's that?
Wow.
This one? Actually, it's not the first. That's the second sensor.
Yeah, the first was thinner, if I remember right. It was etched.
Thing is, this is the first prototype that we showed
The chief
the
scientist.
chief scientist officer for the grant. It is totally hand manufactured. It's like in the 70s, you know, this is totally a maker stuff. Wow, it's been 10 years working together on Mudra.
10 years. It's unbelievable.
Unbelievable.
It's unbelievable, really. It is a big pleasure, I think, on our day-to-day when we sit together. We have the luxury of really developing, you know, and thinking of new ideas and implementing them. And this is like part of I think, the fun part of wearable devices, having these 10 years. Although there's been difficult years, obviously, you know.
I just thought of it, you know, when it was like a baby and everything was new, like 10 years ago, everything was new. If it's on the business part, on the technology part, everything was first time. And now it's like we have new stuff, but it's not like, it's not the same sensation. Maybe you want to go back a bit, remember?
There's nothing like, I think, that sensation. It's nothing that really, you know, there's nothing that can beat that. Although, I think on our day-to-day, unfortunately, we still learn new things. And this is part of the problem, I think, part of the challenge. Because we can't plan it all the way, right? So maybe you can I wanted to ask you about the first time we met.
Okay.
Before the Intel days, maybe.
I see you want to tell about it, so go on. Do you remember when did we first met?
We first met when my first day at Intel, when I started working as a student at Intel, my car just broke down. And it broke down on the beach on the way to Intel. And I was really, really, I didn't know what to do. I was really scared. So I called my boss and I said, I'm going to be late. I'm not going to make it, you know. He said, oh, no problem. I'll send Guy. And you came drove me to so it was really like a nice experience to see that it was, even though like Intel is like a really big company and you're really scared, that there's still some, you know, people who are, you know, make it feel like a regular, you know, place to work where you know the people you work with. So that was really fun.
So when I'm thinking of the first days of us working together, before going into the idea itself, I had something in my head and I told some people. You, I think, just finished your second degree at mathematics and I had this crazy idea and I wanted to see who can, who finds it interesting, because it was really, you know, something very far-fetched those days. And I was talking to several people, including you and Asher. The thing is that, and that's interesting because a lot of people said, wow, it's interesting, but only you and Asher started calling me or meeting me like every other day. When do we start? When is it going to run? And one of the most important things in looking back, in order to succeed, is who are your partners. So, because a lot of things fall apart because you work with the wrong people. And even though it's very, you know, natural. We had our differences, we had things we didn't agree on, but it always stuck together. That's one of the most important things that keeps us here together so long. Well, back in the day, in Intel, we wasn't working on BCIs or anything of the kind. But as a student, I think I told you that once. So I was working for this laboratory in the Technion. It was working on EEG, and they were building like a very premature BCI. It was the first time, I think it was 2005. It was the first time ever seeing this idea. There was someone sitting there with a lot of electrodes entangled with his hair, and they tried to teach him to move a cursor on a screen. And it was so difficult, and it was very noisy, and they didn't succeed in doing that those days. And the only thing it was supposed to do is move a cursor, nothing more than that. But then I was exposed to a lot of videos on work that was done around the world. It included the people with ALS that had an a chip injected into the brain, which is very dangerous, and they could do a lot of things. Like they could control a video game. There was this movie about I think an octopus that was controlling a hand of a robot.
Yeah, I remember.
And he was with BCI, and he was feeding himself with this robot hand. And that's 2005, 2013 when we started. It was very special time because people started talking about wearables. People started talking about the Apple Watch. Pebble was almost out, and technology was started to be very small. And we worked, at Intel on dies, on high-speed serial buses, and we saw how technology is going forward.
Yes, I think also in Intel we saw a lot of how this miniaturization is taking place. So we understood, everybody in this business understands how entire company wanted to do low power. Low power, that was like the goal back then. And so we saw the trajectory. It's going to be smaller, much
And
less
then
energy.
and also I think I read then Yuval Noah Harari's book, and he was talking about how in the future the superhuman that will be like all this technology that today you give disabled people and make them better, and then they become better than a regular person, so that one day everyone will want this disability technology for the everyday man because it will make him it will give him some kind of superpower. These two stories connected, and I said, well, no one will put not a EEG headset on his hand, and of course will not go through a surgery to put a dye in his head, but everyone will want these superpowers. And now we have wearables, it's going this direction, so we can bridge this gap using wearables.
But maybe before you've always been someone who loves making things, right? You've always, was interested. I remember before in wearables and neural technology, also in I remember energy conversion and other cool new ideas. I remember back in the day, and maybe you can tell us a little bit more, like what happened from taking the step from maker to entrepreneurship, like how it all happened.
I always wanted to do something of my own. I always had ideas that I wanted to build. I always tried to build something. It was holograms once, and then it was some, and it always things that are not on the mainstream, that are very interesting, that are like in the fringes.
Yeah.
And I always looked for the thing that I think that I can use. And I think what really with the first trial with the Mudra, when I built the first sensor, I thought, this is going to happen. People will have such a technology. It's just a matter who will do it. I started building it at home, like playing with that. And my day job was Intel. And then after 6, 7 a.m. going home, I was until 3 a.m. working on this little PCB and a little bit on software. And I thought it will never work if I'm doing that alone. And then I met you guys, and we also and you suggested that we will approach a government fund. And when they gave us the money, they said, they gave us the stamp that this is a valid idea.
Yeah, so let's maybe say a few words about this. So the first time we wanted to find some funding, because it's really difficult without the funding, as we know. And so we went to the chief scientist, right? And there is a small grant that you can do if you're doing something really novel. Okay, so something that's I saw this like grant, and it was really like exactly, I think, the thing that gives this ecosystem, enables this ecosystem to happen, because it's not a lot of money, but it's still, like you said, like you mentioned, a strong authentication. So once you have this initial seed money from a chief scientist, someone who has a technology authentication, and so we have investors feel more comfortable to approach you, because okay, another person took a look outside, said, okay, this technology is interesting. So that's really important, to get the buy-in from other people, other people in the field and other people in the innovation field, to see us, to see what we're doing, what's going on, because it's innovation is on the one hand really cool, and the fringes is where things are happening, but also it's where difficulties are, and so you need to overcome them, right? So it was really, really nice that we got that grant, because it put us on the right path, I think, to other investors and other people to see what we're doing.
I really wanted to ask you, because when we started, I'm an electronics engineer, and my knowledge is more into the hardware stuff, and that's why I started with building a sensor, and then that's exactly where you when I first needed your help. Let's do something with that. So we connected it to an Arduino, and then started to take data, and then you started to play with the algorithms, with the first algorithms. We had in the beginning, we used the simplest algorithms, things that you found in some articles. And today we have such a huge database with AI models. So how did it start on your end? How did you approach it?
At the time that it was a special time, the time that we began, like 2013, 14, when things started kicking off. And I think 2012 is the ImageNet competition. Or the end of, sort of the end of my degree, and around the time that, the ImageNet competition happened and deep learning took off. So it was clear from the get-go that you could do more. So if you see something with your eyes, and you know with your own mind that you could classify something, then we knew that in the future it will be possible, right? But the question is, the databases and all this. It's a massive undertaking. So there was I went to consult with a few people from my research team, and we thought of a few families of algorithms, a few things that we could, over the years, sort of try out, things that we could begin with, and things that we could slowly scale up. And but you also, at this time, it wasn't exactly clear how all the deep learning will be applicable to our field. So it was and it still is and was a trial and error procedure where we learn new things. But I think the interesting things we know today, or the things that in hindsight, when we look back at it, when we didn't exactly know, is I think there's two things that we could do here. We could do with Mudra, the things you talk about with BCI, what the BCI adapts to you, and the things that do not require adaptation. And in this is the big, I think, opportunities that we have today of having the machine adapt to us, being able to, with compute and with data, being able to give a better experience. And that's something that, in the beginning we couldn't do, and things we need to scale up a bit in order to do. There's also the database and the annotation and all this, and maybe...
So much work.
This is something... Okay.
Okay. What's that? Okay. Okay. This one? Actually, it's not the first. That's the second sensor.
Yeah, the first was thinner, if I remember right. It was etched.
This one is also hand etched, but the first one was like a square. But the thing is, this is the first prototype that we showed the
chief scientist.
The chief scientist officer, for the grant. It is totally hand manufactured. What it means, I printed the it's like in the 70s, this is totally a maker stuff. It's I took this bare printed board with one side copper, and then you print a circuit on top of a home page, from a magazine or something, and you print on top of it, and then you take how it's called. And you have to put it on the bare board and use like chemical stuff to make the ink go over to the other side. Then you take some other chemicals and they take out all the rest.
But
And
they
it
do
was
this.
a lot
They do
of
this in the
work.
factory. It's been in the factory. It's being done by automatically.
Yes, so now it's
Etching
when you look
lithography.
like if you take this one and this one now here you don't see the electronics, but like if you going to take it on like a time scale, so it's like that. So this is like a first prototype. This is a prototype that you can take out. This was done in a factory, but it's like it made of two main parts: the flex part that connects all the rigid PCBs, and on the other sides the rigid PCBs with electrodes, only for the electrodes. So what we used it so we can check different types of amplifiers, different type of electrodes, and what was always the same was the Bluetooth part that was transmitting everything. And
So
from this to this, it's
this one was the first wireless like Bluetooth one. This one.
this is the first Bluetooth one that we've manufactured. This is actually this was done by Tamar. Tamar.
This was by Lemon guy or something like
Yes, the
that. Chinese
first
guy Lemon guy.
You remember the? No, it's well. There's a funny story. We were still working for Intel, and I was ordering the first batch of PCBs, and then somehow someone hacked our email correspondence with the manufacturer. And he gave his address for the payment.
I'm not sure this is for the podcast.
Anyway, this is our current COO work. She was then working as a industrial engineer, and we hired her as a freelance. And she did like the first idea of how to encapsulate the band, which was so this was Tamar works over then, but now this is Tamar and Arnold's work today.
Maybe the last one you show with Ohad. We'll save it for the best for last.
But from hardware point of view, so this is where we started, and that's where we are today. Wow, all this, I think out of 10 years, it's 6 years only electronics, even 7.
I think if we're looking at the last years, the challenges that we've seen last years, and the maturity that we've been, sort of trying to make the company more mature, trying to bring the product into the market, then this is the big problems where the big funding goes to. It's where we design for manufacturing, the not so fun aspect of work, of making everything exact, or as exact as we can. And this is a different sort of work, I think, in the last years, electronics, but it's not like making something new. It's refining this in order to bring it to flexible electronics. And I think a few words about this. And if we look at other key players in this market, look at the Apple Watch, you look at neural companies in the field like Phison maybe, and a few other small players, no one does this. No one does this. This flex PCB design is extremely difficult to nail, because it's flexible electronics. We see those things in hearing aids, sometimes in elderly. My grandmother has this. She's a very advanced like hearing aid with, that goes all the way inside. And this is really like where electronics, because you're saying electronics, but we don't live in a void. So we do this R&D, and you do this with your hardware team, where we, manufacture flexible watch strap. That's really, I think, a huge like engineering feat to do. And the question is, maybe was it too much? Did we go too far with this? Well, I think because it cost lot of money.
It's an interesting question, but it reminds me of something that I learned from you. Well, everyone look on AI and on machine learning like a magic. You put inside data and then you get some kind of results. This was this finger. I made this. And actually it doesn't work like that. You cannot just put data and get the magic working and get results. The data has to be good. And in order to have good data, you need to have good sensors. You need to have good hardware. In the beginning, we tried to do everything: electronics, electrodes, software, and it took us some time to understand what's important that we will do and what's important that we will use a work that was already done by others. And the thing is that the first thing, the most important thing that you defined it from point of view of the algorithm of getting data that can make sense, was that the band should fit to the hand without moving in a comfortable way. Because if it moves, if it jumps, and if it's not comfortable, then the data will be very noisy. Like the mechanical part, the electrodes touch the body in a snug fit, without moving too much, getting the best kind of signal was the first things that we had to achieve, and that took us a long time.
Yes.
And
yes,
it couldn't happen any other way, because you can, that's the hardest part. And then there was no good solution there that you could just buy and use.
Yes, it's very. I think a lot here is where I think we made one we had a few options and we could have gone another way, I guess. But I think at this point it's exciting to be sort of after this Flex PCB and all that we learned. A few things, and like you're saying, frustrating things. Like the frustrating things could be like, okay, so we build a very nice. If you remember one frustrating thing that we had, so we finished a design. You guys with Michael finished one of the bands, and then we had data coming in from the bands and nothing worked. We recorded and nothing worked. Nothing. And we started thinking what's going on and what could be. And we discovered that after a time, the Bluetooth channels that are being sent are sort of permuted, So channel 1 becomes 3 after like 10 or 15 minutes. Do you remember that bug?
Oh, there was so many, but
that was, I think, the most difficult one of because I built a database around it's algorithms over Bluetooth, right? We're talking here algorithms over Bluetooth. So we're sending the data to another device, and there we're recording and all that. And so every once in a while, you don't remember this, but the channels switched after like 10 minutes, 15 minutes of work. So what happens was that you could have like someone doing we had recordings of people where the channels were mixed up. After recording for a long time, I caught the exact second that it happened. I saw it with my own eyes because I had a hunch, but I saw it happening, and then we fixed this.
Regarding the Flex PCB itself, so yes, it's a huge challenge because the wrist is moving, and if you want to have something that is comfortable, so it cannot be like one cloud of plastic. It has to be moving. It has to be soft. Otherwise, 10 minutes and you want to take it off. So you need something that is flexible, and flexible electronics today are usually used inside a case. So you want to use the flex properties only once. Like if you open the Apple Watch, inside there's a lot of flex electronics. But you opened it once, you put it, then it finds its location, you close it, and that's all. It doesn't move anymore inside. In our case, it moves all the time, and then it creates all kinds of of issues. If the Flex PCB is not made from the correct materials for what is called dynamic Flex PCB, then it will break after a few usages, and you will have all kinds of failures. It took a lot of work, many years of work, with many manufacturers and using external experts to really find the materials that are good for such a device. And no other company is doing exactly such a product. Usually all the companies that tried, even big ones, I remember that we were working with Samsung and they had a band with a camera in the band, and the band was flexible, and they had like such a low yield that they dropped it.
I think, yeah, a lot of things, because like we know what I think something we didn't mention, and something I think we all agreed on, is that maybe why even a wristband? Why do neural on a wrist, right? Why even go there? But before that, I think before even discussing this, which is a question like for you, is what we believe in, like a wristband in general. Like so if we want to introduce like a new device, and we want it to be something, a wearable device, maybe it's sometimes to some people, or it may sound a little bit like it's so simple, it's it's self-explanatory, but we want something that people are already wearing, right? We wanted to think of a device that, you know, seamlessly blends into what we do every day. It cannot be something that a wearable, we don't want to introduce a new category. So all this, the Flex PCB, or the idea of a band is, or at least part of this idea is the fact that we want to do a wearable that is something that is people will want to wear, right? Will want to wear ideally all day. And which is a huge challenge. But maybe you can tell a little bit about like the differences between if we put electrodes on our head and measure and see what we see, and when we see it on the peripherals of our body, how that sort of works out.
I think maybe we have to go a little bit earlier and ask why BCI at all? Why go there?
Yes.
Because I don't think that many people know what BCI is.
I'm getting a signal here. I think we need to, you know, it was really fun, but we need to close it. This part of the, you know, the reminiscence of the old days. We need to do this again, I guess. And thank you, guys.
Thank you, Leeor.